Okay, wonderful people, let's go ahead and get started. So what we're going to be doing today, so it's kind of a little bit more of the same. We're going to apply factoring to solve quadratic equations. So we're actually going to solve them. We're not going to just factor them. So what you need to know about solving quadratics by factoring. So, well, the first thing really we need to do is make sure that it is in the right form. So we want to make sure it's in this standard form of ax squared plus bx plus c. That's the real first step. But then we also have to move all terms to one side. So we try to make it as close to this as we can, but it's got to be equal to 0. Once we have that, we factor it. All right, so there are different ways of factoring it. We can take out the greatest common factor, which I like to call reverse distributive, because everyone knows what distributive is. Then we also have that other method that I like to use. And then after we factor it, you're going to end up with some groups. Set each of those groups of those factors equal to 0. So remember, a factor is a number that you use to multiply, and it can even refer to a group as well. So if we set them equal to 0, we then have to solve each value for x. So we got to find out what the x is going to be. So in most of these, there are going to be 2 of them. So I always tell students that if you have the variable, so like usually when you're solving for x, if you have an x squared, that means you might have 2 possible solutions. All right, and that doesn't mean you're always going to have 2 solutions, but it means that there's a possibility of having 2 solutions. So I'm going to do a quick rundown here because I didn't really write it down, so it's written down now. How to use the Loif method, as I call it. So to do this, we start from the left and go right. So the first thing we do is the last number. So we look at the last number, which is usually this c value here, and we think what 2 numbers can multiply to get c. But we also have to take into consideration the sign, right? That sign is important because you need to know what signs will go in the bubbles. And then your middle step are take those same 2 numbers that you used in step 1 and make sure that they add together to make the middle number, the b value. And the sign also has to matter with that one as well, because the sign will tell you whether you are subtracting them, adding them, or some combination of that, adding and subtracting. And then your first number, the last thing you do is the first number, and that is pick 2 numbers that multiply to the first number. And with some of these, you do have to do a little bit of trial and error, which means see if it works. If it doesn't work, change something and try again. So let's go ahead and solve by factoring these problems here. So it's already as close as we can get to standard form. So it is in descending power, although this one is missing a c value. So that kind of limits the options that we can use for factoring it, but there is one that we can use, and that is to group these first numbers together. So x squared plus 9. And I'm going to put them in a group, and I need to think, what can I factor out from both of those? Now, I know sometimes I say divide, but you know, people know what divide is, but factoring out might be a little bit of a different thing. So remember, this is x times x, and this is 9 times x. Since they are both being multiplied by x, I'm going to remove a factor of x. So again, this is x times x, but now we removed one, so it's only x. This is 9 times x, but we removed the x, and now we just have 9. Now, I need to set each of these sets, these groups, to 0. And sometimes I think it helps students just figure out, makes it a little bit more clear to group this first number, even though it's a group of 1 item. So we set that first group to 0, so we get x equals 0. And actually we're done with this one here because we know that x is equal to 0. Okay, so let's go ahead and take this group now, and I'm going to put x plus 9 equals 0, and I'm going to minus 9 from both sides, and that should give me my solution here. So again, we might have two solutions, which I think most of these are going to have two solutions. So 0 minus 9 is negative 9. So now we have both solutions. But we also have to write it in solution set form. Solution set form, x equals, and we're going to use braces. That means these curvy parentheses here that kind of look like a musical note or something. I'm not really sure. But that means set. So again, since there's more than one answer, more than one solution, let's go ahead and put them in here. So x can be equal to 9, or sorry, negative 9, or 0. Now, if I plug these numbers back into the original, it should be a true statement. So negative 9, okay, let's just do this in our heads. Negative 9 squared is, well, negative 9 times negative 9 is 81, so positive 81. But negative 9 times positive 9 is negative 81. So we get 81 minus 81, which is 0, which is true. So that means this is a solution because 0 equals 0. They balance out the equation. And here, if I plug in 0, okay, so 0 squared, that would be 0. 9 times 0 is 0. 0 plus 0 is 0. That's also true, so that's why it works. That's why we call our solutions zeros. So if you remember from yesterday, when we were talking about them, we call them roots, x-intercepts, or zeros was one of the ones. That's why we call them zeros, because that's where it crosses. If it was a parabola, one would cross at negative 9 and the other would cross at 0. And our parabola would look something like that. Okay, that's not the best drawing ever, but you know, hopefully you get the idea. It would look something like that. But it would cross at negative 9 and 0. All right, so let's go ahead and do this one. So I always say this, it's not division, it's factoring. So what exactly does it mean and how is it different? So I'm gonna show you this time around. I'm gonna show you each and every step. So I'm gonna break this down into everything. I'm gonna break it all the way down. 4 times 1 times x times x. And that's all 4x squared, right? X times x is x squared. 4 times 1 is 4, and they're multiplied together. Negative 1 times 4 times 2. Now you're probably wondering why I didn't factor it down all the way, which you could do that. But I want to see what I can take away from both of them. So I know when I say take away, people think of subtraction, but we're not subtracting, and you might even say we're doing division. But I'm going to say we're not doing division because when you divide something, it's being reduced. We're not reducing anything, we're just moving things around. So we take out a 4 because both of these terms have a 4, and we take out an x because both of them have an x. So we're going to take out the 4 and x, and let's see what we have left. So 1 times x is just going to be x, minus, so the minus is still there, we didn't do anything to get rid of it, 2. So x minus 2, and if we multiply this out using distributive property, we should get our original question or original problem back, which we don't really need that. We're moving ahead. We're going to be doing factoring. So let's go ahead and take both of these and set them equal to 0. Now, when we set them equal to 0, we are using what's called the zero product property. And I should probably take a second or two to write this out, but zero product property basically states this. So we know that 1 times any number, I'm sorry, not 1, 0 times any number is going to be 0. So 0 times 6 is 0. We could also write it as n, or in this case, I'll write it as b. 0 times b equals 0. Now, what if I told you that we don't know either of these? A or B times each other is going to be 0. Now, with this rule, it basically means that one or even both of them could be 0. So that's basically the zero product property. And that's why we call the solution zeros as well. All right, so I'm going to continue solving for here. So I'm going to just use regular algebra, divide both sides by 4, and I get my first solution. It's x equals 0. Let me try this one, and I am going to add 2 to both sides. So if I add 2 to both sides, that is going to make my second solution 2. So I have the solution of 0 and 2. Now this doesn't mean that it is going to be 0, but okay, so in this case here, if I plug 0 back in, yeah, if I times anything by 0, it's going to be 0. But if I also put 2 in here, you know, all this is going to 0 out. So let's go ahead and put it into our solution notation. 0 and 2. And there we go. We are done with this first one. So we got quite a bit of problems to cover. So I'm going to kind of keep the pace moving a little bit. And let's go to the next one. So remember, there are different styles of factoring. This was one of the special cases that we covered before. This is what we would call a square roots, a difference in squares. There you go. So we call this a difference in squares. Now, if you want to turn it into standard form, this here, all right, so let's make our x squared go first. But what happened to our b value? So our b value is 0 because there is no lone x number. That 4 is actually a c value. Now, if you don't remember the shortcut, you can always expand it out, writing all of the terms. So in this case, I just replaced b with a 0. All right, now we can bring up our formula, the one we use. So last numbers, I need 2 numbers that multiply to 4. But remember, this sign also has to be taken into consideration. So the only way I can multiply to get -4 is if one is positive and the other is negative. Because if you multiply 2 negatives, you will still get a positive. And now, well, 2 minus 2 is 0. So that takes care of our OI. Now our first term is going to be x because x times x is x squared. Now we break these down into 2 separate problems and set them each equal to 0. So x plus 2 equals 0 and x minus 2 equals 0. I am going to just use my regular algebra. And since these 2 problems are very similar, I guess I can go ahead and just do them at the same time. So again, what number can I add to 2 to get 0? Well, -2 plus 2 is 0. So that must mean that x is -2. But we also have a second option, because again, if you have a 2 power, you might have 2 solutions. All right, so in this case here, I add 2 to both sides and x equals 2. Now it's completely solved. So remember, solving means to get this variable by itself, which we did. The variable is entirely by itself. And I like to put my solutions in numerical order, so the less number to the greatest number. So negative numbers are always less than positive numbers, so I'm going to make them go first. Although this is not a really big rule, okay? You don't have to do it every single time, and I'm not going to mark you points if you don't put it in the right order. So if you put 2 and -2, you know what, I'll take it. In fact, I might even do that a couple times in this lesson myself. All right, so now that we know these are difference in squares, because this is a square number, 9 is a square number, this is a square number, x squared is a square number, and 25 is a square number. So I'm going to use the shortcut for these ones, and that is I am going to take the square root of both sides. Now, because this negative 25 is our C value, that means they will be opposites. And that makes sense because we don't have a B value, because if we use FOIL, we get like 2x minus 2x, which is going to be 0x. So that's why it's gone. All right, so I'm going to take the square root of 9x squared, so that's going to be 3x, and take the square root of 5, so that's going to be 5 here, 5 there. And now we set it equal to 0 because we need to use zero product property. 3x plus 5 equals 0. That's not a very good plus sign. 3x minus 5 equals 0. Now I'm going to have to do a little bit of work on these here. So I'm going to minus 5 on both sides here. 3x equals negative 5. So what number can I times by 3 to get negative 5? All right, and if nothing comes to your mind, that's fine, because actually it's going to be a fraction. So I'm going to cancel out the 3. Now x is by itself. So again, inverse property. So if it says 3 times x, we divide both sides by 3 to get rid of that 3. So that's our first solution, is x equals negative 5 over 3. And I'm going to go ahead and do the same with this side here. And it's very similar to the first one, because I'm going to add 5 to both sides, and that gives me 3x equals 5, because I added 5 to both sides. Divide both sides by 3. And this is going to be positive 5/3. And those are the two solutions that we are looking for. All right, so you got that. And this lesson is, I think I'm in, it's a bit of a longer one, like yesterday. So I'm going to keep things moving along. All right, number 5. So in this case here, we have trinomial, right? So we have 3 terms, and it is in standard form, which is great. So this means the only thing we have to do is our factoring. We got to take it apart. So we know FOIL, that means we multiply 4 different numbers together, but we got to undo that. So again, this is an easy way to remember it, and it's just FOIL backwards. So start off with our double bubble. Now I need 2 numbers that multiply to 21. So think of 2 numbers that multiply to 21, which there's probably that's going to be the first to come to most people's mind. Now, remember, when you are working with this, you got to take the sign into consideration. That sign is part of that number. So I have 21, but it's positive 21. So you might be thinking, well, aren't they both positive? But remember, this OI is your outside-inside number added together. So in this case here, it would make them both negative. Yeah, you got it. They're both negative. But like I tell you, the way you can kind of shortcut this is the second operation, which there are 2 things going on here. The second operation, if it's an addition or a plus, that means they are the same. It doesn't mean they're both positive. It means they are the same. If they are the same, they are the same as whatever the first one is. So now we know that -3 and -7 will combine to make -10. So we know this is the right answer. And then, last thing we do is actually the first thing, or the first term, which is x times x, which is x squared. So now we have, and we could check it, which I just did check it when I explained it to you that, it'll work out. So test these, all right? Don't forget to test your factors. Multiply them back out and see if you get the same thing. I know a lot of times students don't want to do that because they feel like it's doing the whole problem over again. But if you were kind of paying attention and you weren't really listening, you know, I could have explained how I checked it and it would have only taken like 3 seconds. 3 seconds, you know. Continue solving. We want to get these numbers by themselves. So it looks like I gotta add something to both of these. So in this case, I get x equals add 3 to both sides. Over here, add 7 to both sides. And you're also going to kind of notice a pattern as well. This is one of those other, it's not really a shortcut, but it's a way to just sort of remove one step. So to remove one step, you notice that this is -3, but when I make the solution, it's +3, -7, +7. Yeah, you're basically just reversing the sign. Now be careful because sometimes you will get something that is a fraction or something like that. Usually it's fractions and they can be a little bit more trickier, but it's still roughly the same thing. But anyway, there we go. We got our two solutions, 3 and 7. So this is a parabola passing the x-axis at 3 and 7. Now you're probably looking at this next one, number 6, and thinking, oh boy, this is one of those ones that's going to take a while. But we can do something to make it a little bit easier. Now, I don't know if you have to do this. I think you can get it without doing this step, but it's usually recommended. All right. And again, I've been doing this so long, I don't even know if it'll work if I just double bubble it for now. But the first thing we'd have to do is look at all 3 of these numbers and think, is there a number I can divide all of those 3 numbers by, the same number? Yeah, it's 2, which you can see I already wrote that. So I'm going to divide everything by 2. Now remember, this is 2 times 1. So I took out the 2 and left the 1. And that same thing happened for this one here. And 24 is 2 times 12. Take out the 2 and we are left with 12. So again, it's not really division. But in this case here, yesterday I told you this 2 is important. Don't forget that 2. But when you're solving it, it's not as important because if I were to group this like I did on the other ones, I get 2 equals 0, which 2 is not equal to 0. That's false. So we disregard that. So we're going to focus on this part here, our trinomial, and I am going to double bubble it. And think of 2 numbers that multiply to 12. Now, remember, it's -12. The only way you can multiply and get a negative number is if one of them is negative and the other is positive. All right, so let's see. In my comment section, I got a 3 and 4, or my chat, I should say. And now we have to make one of these negative. Which one would be negative? Now there is a little bit of a clue here that you can use to get it, which is this one right here. So our first operation, remember when they're the same, it's both going to be the same one. So this means, let's see what we got. The 4 is the negative one. Okay, there you go. So thanks, you got it. Now we know the 4 is the negative number because 3 minus 4 is negative x. Whereas if I switched it, so the 3 was the negative, 4 minus 3 would be plus 1x, or positive 1x, plus 1x, or just plus x. So that's a way you can, you know, so we did check it. All right, we made sure it worked because we used our LOIF, and now our first number is just x because there's nothing in front of there, so we don't have to do anything much else. And now we have to set them equal to 0. So x minus 4 equals 0 and x plus 3 is 0. And just do the inverse. So my first solution is x equals -3. And over here it's going to be 4. So x equals 4. And there we go. We have our 2 solutions ready to go. And they're already in numerical order. So I'm going to go ahead and just write it in set notation. So -3 and 4 are the solutions we got for this one. Now again, this means if I plug 4 in for x here, it's gonna zero out. It's gonna become 0, which is gonna be true because this side is 0. And this is not the only method. There's another method called completing the square where you don't set the other side to 0. But that will be another lesson for another day. All right, so now moving on to 7 and 8. So whenever you have an a value, check to make sure you can't divide something out, or again, factor something out. And you might be looking at this and then think, well, I could divide everything by 3. Well, 3 divides by 3, 30 divides by 3, but 13 does not divide by 3. So we can't do anything about this one. We're just gonna have to move forward with what we have here. So now I need 2 numbers that multiply to 30. So we're gonna make a short factor list, 1 times 30 and 2. Can I multiply something by 2 to get 30? Yeah, okay, so 15, 3 times 10 is 30. And it looks like we already got 1. 5 and 6 is the suggested one that we use. And yeah, 5 and 6 are probably the best ones to choose, because when choosing factors, you want the ones that are closest together. Now that's not always gonna be the right one the first time, but if you have to kind of guess, which is what we're doing, we're solving by trial, which means we guess at it. If it doesn't work, we try something else. All right, like playing a video game. And I'm gonna randomly assign one to be positive and the other to be negative, because, well, this is negative, and right now we don't know which one it is, because this 3x kind of makes it a wild card, right? And in this case here, 3 times -6, or actually, let's do the whole thing out. So 3x squared. So first number, outside number, is -18x plus 5x. And if I check it now, 5 minus 18 is -13. And we actually managed to guess it right on the first try. And I was kind of hoping we wouldn't guess it right on the first try, because, you know, it kind of shows you that it's okay to make mistakes. It's okay to try something different. All right, so like I said, playing a video game, a lot of times it's not really about skill. If you're playing like single player, it's not about skill. It's a lot of times it's just about memorization. You know, where the foe is going to pop out from. You know, what's the timing to make the jump? You know, for the gap or whatever. You know, what is the boss's pattern? Those are all things that you learn by playing, and you never get them right the first time. So I mean, I doubt it. You know, if you could get like someone to play, you know, an adventure game and somehow get through the whole thing on the hardest difficulty without ever losing, yeah, that's impossible. You know, you're always going to lose a few times, but it's never the end. You just try again. All right, so there we go. So I solved both of them. So x equals -5/3. And let's see what we're going to say about this here. Yeah, so that one's going to be a fraction on that one. So if you can't divide it nicely, and a lot of times when you have these a values here, that's usually a hint that it is going to become a fraction. And in this case, I'm going to leave it as a fraction. You know, I could easily turn this into a, actually, this one does not turn into a decimal, because if I turned it into a decimal, I'm sure we're going to get a repeating decimal. 5 divided by 3 is 1.6666, so that would be -1.6666. And in this case, yeah, it's better to just leave it as a fraction. But anyway, there we go. There's our solution for that one. Let's move on to this next one. So we're moving along. Okay. All right, so I need two numbers that multiply to 4. And I'm probably going to get 2 and 2. That's going to be the big one. But again, it's a negative. That negative means that these two are going to be different, because the only way to multiply to get a negative is if one of them is negative, which also means I'm going to have to subtract one of these from the other to get 5. Now, 6 is a bit of an oddball one because I don't know if this is going to work. So let's try 2x and 3x and multiply it out to test it. So 3x times 2x is 6x squared. And this is going to be 3x times negative 2, so that's going to be negative 6x. Inside term is going to be 4x. Now, if I had 4 minus 6, that is not going to give me 5, so this is not going to work out. We're going to have to try something else. Now, I can't switch out 2 and 2 because it wouldn't change anything. So I'm going to switch out here. I'm going to put 2x here, and I'm going to move 3x here. So I'm going to swap the first number place first, and let's see if that one works out. So let's test that out. So 2 times 3 is 6. Okay, so x times x is also x squared. This is negative 4x, and this is going to be plus 6x. So this is also not going to work out. All right, so let's go with your idea and multiply 1 and 4 and see if that works out. So we tried the factors, right? So we tried 2 and 2. We even tried switching the place of the other number, and that didn't work out. So we're going to try 1 and 4. We're going to try a different set of factors. And again, usually picking the two closest ones works the best. Most often, you will have to guess fewer times, but sometimes you will have to change it. So let's try this one out. So multiply our first numbers. Okay, works out. 2 times negative 4 is negative 8. And 1 times 3 is 3x. Oopsie, this one's also supposed to be an x as well. But you notice we get 3 minus 8, which is negative 5. So we're close. That's not, this means we are very close. We only have to switch one thing. If you get the same number, okay, so some people will argue with me saying, oh, but it's not the same number. And I say this too, right? I'll tell you 5 and negative 5 are two entirely different numbers. But at least the absolute value is the same. So they're both 5, but one is negative 5 and we need positive 5. So if I switch the sign, that should fix it. 2 times 4 is positive 8x, and negative 1 times 3x is minus 3x. So 8 minus 3 is 5x. So we know this is the correct combination of numbers and factors that we need. Whew, okay, so we checked it and it worked out. And with these ones, again, you gotta have to solve by trial, which means you gotta try different things. And I know some students, they don't like that. They don't like a process that, I think they feel comfortable with something that you can follow the steps and get it right the first time, every time. But not everything is like that, and math, is usually no exception. You're not going to get the right thing every single time, and that's just the way life in general is. You are going to make mistakes, but the important thing is that you learn from those mistakes and don't let those mistakes hold you back, but make them a chance to try again. So we are done with this one here. I just used my basic algebra, solved it, add something to both sides, minus something to both sides, divide both sides, and we got it. So there we go. Moving on. Moving along and singing a song. All right, these ones are a little bit different because they're not in standard form. All right, so if they're not in standard form, we are going to have to put them in standard form. And this is that step 1 that they talked about on the first slide, is we got to move everything to one side. And that usually means, again, putting it in standard form. Now, sometimes you'll have to move Okay, so the question for this one is, do we move like 2x squared or do we move 5x? So do we minus this or do we minus that? And this is one of those other things that I've done it the same way so many times that even I myself don't know what happens if I don't follow this rule. But the rule kind of that I go with is keep your x square number, your a value, keep it positive. And that usually makes it easier, if not always possible. So again, I don't know if you can even do it the other way. Yeah, and since we canceled this, we're going to put a 0 there. So 2x squared minus 5x, and again, we got to set it equal to 0. So that was the second step, I think. Or was it? I think it's still the first step. I don't know. Anyway, let's go ahead and remove a factor. So I only have 2 terms. So this means that I'm going to be stuck with greatest common factor or reverse distributive. And I'm going to take something from both of them out. Since 2 and 5 don't have any numbers, we're going to have to take one of their letters. So we take an x away from both of them. And in this first one here, x is already solved. So we know one of the solutions is 0, but we need to spend a little bit of time to find out what the other solution is. So I'm going to set that to 0, and I'm going to have to do some algebra, some inverse operation. So if it says minus 5, well, we got to do the opposite and add 5 to both sides. If it says 2 times x, we do the opposite and divide both sides by x. And there we go. So now it's by itself. X equals 5 over 2. Let's write that in our form, set builder set form. And that's all these braces mean. It means the set of, so like sometimes they might have something like the set of even numbers, and this is usually one of those really advanced math course things. But you could also have like the set of mammals or set of numbers that are possible on a dice sort of thing. But it just means, oh man, those are some of the worst braces I've seen all day. Well, you know what they are. All right, let's go ahead and get this one, and I'm going to solve this one and set it equal to 0. Now again, we want everything to be gone off of this side here. So 7x minus 1x, well actually x squared, minus 8x equals 0, because there's nothing left on this side. Everything canceled off, so it's now 0. And again, this is as close to standard form as we can get. So, but in this case, both numbers are even. 6 and 8 are even numbers, so we can take out 2, and they both have x, so we're going to take out 2x. And I think even if you don't do this step, I think it'll still work out, because you would have to reduce the fraction in the last step. But let's stick to the same process, because this process works for other kind of problems too. All right, so 6 is made from 2 times 3. Take out the 2, we're left with 3. 2 times 4 is 8. Take out the 2, leave the 4. Oh yeah, and we also took the x, so there's no x here as well. So that's again, that's factoring. You're taking one of the numbers that we multiply out. So in this case, we took 2 out of that. So 2x equals 0, and 3x minus 4 equals 0. And divide both sides by 2, which this is an easy one because, well, 0 divided by 2 would be 0 always. And for this one here, again, I think even if you didn't factor out the 2, like let's just say you forgot it, in this case here, it would probably still work out, because then okay, so if we did this, it would be 6 over 8, which would still cancel out. Oopsie, I was thinking of 8 in the back of my head. But if I divide both sides by 3, that's going to cancel out. But then if I didn't reduce it, okay, I'm probably just confusing you even more. But we would still get the same thing. That's what I'm getting at. And again, I'm going to put them in order. So by putting them in order, we have 0 go first. So x equals 0. And 4/3. And this is another number that you can't really put into decimal form. If I tried to put it in decimal form, I would get a repeating decimal. So it's probably just easier to leave it as a fraction. And fractions are not that bad once you get to know them. I know people are always scared of fractions, and your mom would probably scare you at night telling you that fractions are outside to get you or something like that, to make you stay inside. But honestly, fractions get a bad rap. All right, so now we're moving into some more of these where they do not have the number, it's not put in standard form already. So we're gonna have to do a little bit of work to make sure they are, no, it wouldn't be digis. It would be more like, sure, a swoosh, damn fractions, or something like that. All right, I know the natives in the group are going to be blasting me saying, oh, he pronounced it wrong. All right, fine. I haven't said it in a long time, but I still know what it would be. All right, so I'm going to go ahead and I'm going to minus, since this is -1, I'm going to have to cancel that out by adding 1 to both sides. Oopsie. And I'm also going to have to get rid of this, which means I'm going to have to minus x squared from both sides. So combine them on this side equals 0. And at this point, we notice that this is a difference in squares. So a difference in squares should be a little bit easier for us to do. So a difference in squares is going to be, well, we can use the shortcut. We know that they are going to be different. And we know that it's going to be the square root of both of these things. So take the root of 49, and that's going to be 7. And we can check it really quick. And if I check the outside numbers, that's going to be negative 7x plus 7x, which is 0x, which is why there's no b value. Positive 7 times negative 7 is negative 49. So we got that kind of done. And I did mention, like, by the second slide or so that we were basically going to reverse the sign of each of these numbers here. So actually, without really doing a whole lot of work, I'm going to go ahead and skip a few steps and say that this first one is negative 7. And if I take the opposite of negative 7, that would be positive 7. And again, it would look something like this. And a lot of students I know they will opt to do this because, you know, it saves yourself a little bit of writing, and that's how I got the first one. And you would do the same thing for the second one, but again, I think some people are catching on to that. Okay, now we got to keep this one positive. So that means I'm going to have to minus 81 from both sides. And I am also going to add x squared to both sides. Now, okay, this cancels, that cancels. So this should be 0 on this side. There's nothing left. So I got to make sure I put the right terms together, which I don't have a whole lot of space to work with here. So I'm just going to have to kind of 3x squared plus x squared is 4x squared minus 81. And again, we do have another difference in squares. 4 is a square number, x squared is a square number, and 81 is a square number. So they're all, 3 of them are square numbers. So we're going to go ahead and reduce, let's stick with our process. So I'm going to put my double bubble there. 2 numbers that multiply to 81, which would be pretty easy. We know they're going to be different because this c value is negative. That means this number here is negative. And now I need to take the square root of 2, well, I need to take the square root of 4x squared, which is 2x and 2x. So that means there's a 2x in each of those. And again, we can check it. But again, I already know the rule through and through, so I know this is going to be the right answer. Set it equal to 0. And now this one here, I am going to go ahead and do the long way around because oh, I didn't set this one to 0. And if it helps, sometimes I put a little wall in there to make sure I keep them separate, especially on times I'm writing them very close to each other. So minus 9 from each side, and this is 2x equals negative 9, and divide both sides by 2. Now x is by itself, and I have my first solution. And for this one, it's going to be a very similar process. I'm going to add 9 to both sides. And this is just, again, basic old division. I mean, sorry, not division, algebra. I'm just doing some regular old solving. So this one is negative 9/2, and that is positive 9/2. So I just need to write out my solution. So x is equal to negative 9/2 and positive 9/2. So now I have both of those there. Now, when, well, just to give you an idea, if this were a parabola, 9/2 is 4.5. So negative 4.5, positive 4.5, and our parabola would go through and do something like that. Okay, I made a little bit of a mistake here. I don't know if I should fix that. But anyway, we're not really graphing it. I'm just reminding you that these parabolas and the factors are looking for the same thing. And they're just different ways of getting the same thing. All right, so let's go ahead and move on to the next set. And I think we don't have that many more to go. We just have 2 more after this one. But again, it's going to take a while. Okay, so let's go ahead and minus 80 from both sides here. So minus 80, and make sure I minus 80 from this side. That's all this wall does is 4 more years. No, I'm kidding. I just said that because the comment said 4 more. I think they meant 4 more problems, and I don't really mean 4 more years. In fact, well, all right, so there you go. I set it equal to 80, or in this case, negative 80. But we have 6 more problems. So now I need 2 numbers that multiply to 80, but if I take one and subtract it from the other, I get 2. And there's a lot of numbers. Okay, we could make the chart 1 times 80, 2 times 40, 4 times 16, 8 times 10, and I think that's going to be all of it. But again, we need one with a difference of 2, so it's going to be this set here. But keep in mind that one is negative and the other is positive, so that's one thing we can do to plan ahead. So that sign means one is plus and the other is minus. Now the question is the 8 the plus or the minus? And if so, does that make the 10 the plus or the minus? All right, so again, if you look at the first sign, yeah, you got it. The 8 is the negative one, the negative number, and 10 is the positive. Yeah, you got it. See, you already know because this is a positive number, and that means that your larger is going to, the larger number is going to be the positive one, the bigger number, as I say, bigger, not greater. So let's go ahead and solve each of these. And again, this is kind of a, I don't know, I'm just doing a lot of writing here, but I don't want to forget any steps. So I'm also going to minus 10 while I'm here, because it's just one step of one thing. So in this case here, x is equal to 0 plus 8, which 0 plus 8 is 8, and x equals 10, or actually in this case, negative 10, because 0 minus 10. Now I'm going to go ahead and put them again in order from least to greatest. So negative 10 and 8. That 10 looks a little bit weird, so I'm going to fix that. It looks more like a weird symbol of a language in another language. All right. So we're done with that one. Let's move on to number 14. So it looks like we're going to have to do a little bit of moving stuff around. So minus x. So I'm going to try to keep this one with the terms the same. There we go. So make sure we did the same thing to both sides, because I do this with students because I want to make sure they know to do something to both sides, because a lot of times they'll either do it to only one side or they'll do it to the same side. You know, if they're like say minusing 4 in this case, they might minus 4 from the same side, which you don't need to do that. So let's go ahead and rewrite our new trinomial. So x squared minus 10x plus 25. And this might be the easiest one we've done all day. I'm sure you can just look at this one by now if you've been following along. This one should just like pop right out at you. So what are two numbers that multiply to 25, but if I add those same numbers, I will get negative 10. So again, this means they will be the same and they will both be negative. 5 times, well, in this case, negative 5 times negative 5 is positive 25. And negative 5, another negative 5 is negative 10. So we need both of them to be negative 10. And we could check it out really quick. Negative 5x, yeah, that's going to make negative 10x. Negative 5 times negative 5 is 25. So again, be careful with those signs. And I said before, students will oftentimes get the numbers right, but their signs are often the thing that's the wrong thing if they get the wrong question. Now in this case, I end up with two identical bubbles, meaning that both of them have the exact same thing in them. They're both x minus 5. So if I were to solve each of them, it would kind of be a bit of a waste of time, because I would do the exact same thing to the other problem. So in this case, I'm only going to do one of them because they are the same thing. And this is an example of what we would call one solution. So if this was a parabola, which I'll just go ahead and make a little parabola down here to show you what it would look like. If we were making a parabola, oops, this. Oh no. Okay, I made a small mistake. Now this should be plus. I switched it to a negative, but I guess you were right. No, you were right. You were right. Thanks for catching that. So that would actually make this one negative, because I'd be minusing both sides on that. Well, all right. Well, good looking out then. So in this case here, the x-axis is not really crossed. It's one of those things where it comes down, touches, and just sort of goes off again. Like when you see a dog on the outside, and then you boop it on the nose, and then you go off, never to see it again. Kind of like that. But anyway, yeah, we have one solution. So there's only one intersection. Well, it's not really crossing, but it's more one point of contact with the x-axis, and that is at -5. So we only have one solution. Now, again, when you have a problem with an x squared or a variable squared, that means you might have two solutions, but that doesn't mean you will always have two solutions. So in this case, we have only one number, and we put it into a set notation, which is kind of weird because you think about it, you can't really have a set of one. But anyway, I'm going to put it in set notation anyway. Moving on. Okay, so, ooh, boy, another one where we have to do a little bit of moving stuff around first. So I'm going to go ahead and minus x squared from both of these. And I'm going to keep things a little bit consistent. So add x, add x. All right, so cancel, cancel. Make sure everything cancels. So we've got to make it equal to 0. So x squared negative 8x. Wait, make sure I got it right this time. All right. And 65. Now I need two numbers that I multiply to get negative 65. But if I add one to the other, I will get negative 8. So I know I'm going to get probably one of them positive and the other negative. So, okay, we got the suggestion of 5 and 13. Let's go ahead and put 5 and 13 in there. And in this case here, I'm not even sure if that's going to work. But let's test it out. And again, some of these problems, you got to try them out a few times, and they may or may not work out. So x times x is x squared. And this is going to be plus x times 13 is plus 13x, and we get negative 5x. And you notice that we get positive 8 because 13 minus 5 is positive 8. But this is a very simple fix. We got the right number, but we got the wrong sign. So let's go ahead and switch the sign. So yeah, this one will be positive and this one will be negative. But again, sometimes you just got to be not afraid to forget. Not afraid to make a mistake. Okay, we can't let mistakes or fear of mistakes hold us back. And again, we got to try several things sometimes. You know, I know we like to think of life. You know, a lot of people, they think life is like, you know what you want to do and you go do it. But it's not always that way. And, you know, it's sort of like finding a job also. Sometimes you think you really want a job, but then later on you decide you don't want it. You know, like for instance, if you like animals, you might decide, ooh, I'm gonna go become a vet because I get to hang out with animals all day and make them healthy again. But sometimes that's kind of a sad thing, because I knew somebody who was like that, and they did become a vet, and they realized that, you know, you're gonna be spending a lot of your time with animals that you can't help, or animals that are suffering and they can't tell you what's wrong. And, you know, it just didn't work out. So even though it seemed like a really good idea, it just didn't quite work out the way it was. So, you know, you might, in that case, you know, try something else where you're helping animals and you don't have to, you know, get down because, you know, be in a down mood because you're surrounded by negativity that you can't really do anything to help. But again, the point of that is sometimes things don't work out, so you try something else. All right, so let's go ahead and do this one here. So minus 2, and this is a regular number, so I'm going to have to minus it from the 98. And over here, I'm going to add 3x, and I'm going to add that to the other x number on this side. All right, I'm going to just do that whole thing over again. That was not very good, 3x. All right, there we go. So cancel, cancel. So there's nothing left on this side except 0, or what should be 0. 4x squared, and this is going to be 44x, and this is going to be 98 minus 2, which is 96. Now you might be looking at this and think, oh man, I need two numbers that multiply to 96, but we don't need to. We can get smaller numbers to work with, because all three of these numbers can be divided by 4. All right, so let's take out a factor of 4. So 4 times 1. So we take out the 4, leave the 1. Now 4 times what gives me 44? 4 times 11, right? Take out the 4, leave the 11. 4 times what gives me 96? 24, so right? 4 times 24, take out the 4, leave the 24. There we go. Now we factored it. So let's go ahead and do, the Loif method with this. And I need two numbers that multiply to 24. And one is going to be positive and the other is going to be negative because I need this to multiply out to negative 24. So I need two numbers that if I subtract one from the other, I get 11. So we could try 4 times 6, but if we can't really minus it, so that's not going to work. So let's try 8 and 3. So that's the suggestion I got. And let's see if this works out. So x times x is x squared. Negative 3x plus 8x. Oh, darn it. You know, I thought to myself, you know, that should work out. But I did it again. I accidentally left out the negative. It's the end of the day. So all we have to do, like you said, is make this into a positive. You know, we don't have to do the whole thing over. We just look at the parts that are affected by the thing we missed out. And this is actually going to be a little bit easier. So we now know both of our solutions and set them equal to 0. So 8 plus x and x plus 3. And I know this is going to be x equals negative 8 and negative 3. And it looks like that one is solved. Whew. So far, we haven't had very many incorrect guesses. We must be doing a pretty good job at the guesswork. All right, so now here we are, the final slide. It sounds way more epic when you say the final slide rather than the last slide. Like the last slide doesn't sound that cool, but then you say the final slide. No, I'm not going to be doing that every single time. All right, so I got a minus 21 from both sides as well. So I'm going to just take all this and move it over here. So 2x squared minus x minus 21. And this one's actually kind of an easy one because there really aren't a whole bunch of numbers we can use to multiply to get 21. If I said to think of two numbers to multiply to 21, everyone's going to come up with the same thing. And that is actually most likely the one that we are going to need. And that is going to be 3 times 7. Don't lie, that's exactly what you were thinking. But it needs to be negative, so one of them has to be positive and the other has to be negative. So let's go ahead and just assign, you know, I don't know which one it is. Could be either one of these. And let's try it out. 2x times x is 2x squared. And 2x times 7 is 14x. Inside is negative 3x. And this is not going to work out. So we're going to need to switch something. So let's switch 3 and 7. So 7 and 3. And see if this works out. Okay, and now we multiply it out. So 2x plus 3 is 6x. And inside is negative 7. Now in this case, it looks like we got it to work pretty well. 6 minus 7 is going to make it negative 1. And if like, let's say we were working with this and we got positive x, positive 1x, all we would need to do is switch the sign. So it looks like we got this one pretty well. Now, when you're making guesses, try to come up with a system so that you don't come up with the same guess over and over again. Because I will get students that will say, you know, I've tried this 10 times already and I can't seem to get it. But then you look at the work and it's like they're guessing the same thing each time. So you got to come up with a way of switching one thing at a time and not switching it so that you get the same thing that you had before. And in this case, I think we are done. We just need to set it to 0 and solve it. All righty, add 7 to both sides. 2x equals 7, and then divide both sides by 2. And now we have our first solution. And here I'm going to minus 3 from both sides. And that should be our second solution, which I'm going to go ahead and look at it. And this is the negative, so I'm going to put it first. So negative 3 and positive 7/2. And there we go. It looks like we got it pretty easily. And again, some of these you might have to guess a lot, okay? Somehow we're guessing pretty well. We're doing pretty good guesses. And there are a lot of strategies that you can do to get good guesses. Like I said, pick numbers that are factors close to each other. You know, like for instance, with 21, you would pick 3 and 7 because those are closer to each other than 1 times 21. Or 1 and 21. All right, last one. I mean, the final question. All right, so let's go ahead and minus x from both sides, but it looks like I'm also going to have to add 9 to both sides. Okay, so canceled and canceled. Negative 12x and 9. Okay, so I'm not combining 9 with anything, so it's going to stay the same way. All right, that looks about right. Make sure I didn't accidentally leave anything out again. All right, so now I need 2 numbers that multiply to 9. Okay, and again, our best luck is to do it this way. And this sign means that they will be the same and they will both be negative because the first one is negative. So that means that these signs in the bubbles are both going to be negative numbers. And now I need 2 numbers that multiply to 4x squared, which we'd have to have an x on each of these, but let's try 2 times 2 to make 4. And let's see if this works out. So 2 times 2 is 4. X times x is x squared. 2x times negative 3 is negative 6x, which is actually the same thing in my middle numbers here, my inside numbers. Negative 3 times 2x is also negative 6x. Negative 6 and negative 6, put them together, you get negative 12x. Negative 3 times negative 3 is positive 9. So we checked it, it works out. And we end up with another problem where we end up with the exact same thing in both parentheses, in both groups, in both bubbles. So in this case, I can save myself a little bit of time by only doing one of them because, you know, whatever I do to one, I'm going to have to do the exact same thing to the other. And I am going to get the exact same solution. So this is another one of those instances where we have one solution. Somebody already bolted for the door. Anyway. Well, we finished right on, well, not right on time, but finished at the bell. So we got one solution. So this is a 1.5. So again, if I were gonna graph this, 1.5 would be like right there. The graph's not really to scale. It would cross at 9. So it would be a fairly narrow graph like this, and it would, again, barely touch at 1.5 and then head back up. Whereas this one here would cross twice. It would cross at -3 and 3.5, and it would cross way down below. So if we had to graph it on a standard graph, it would look something like that. But anyway, that is it for today. Let me go ahead and wrap this up. So I think that's pretty much it. There's not really any announcements this week. So if you have any questions, I'll be around for a bit. If not, then I will see you later. Bye-bye.